Hi, everybody. So as we start filtering in here, want to thank everybody for joining us for the Energy Storage Market Series. We're joined today by Devin Wilson from BYD and Terrence Parker from Solis. Before we jump into letting Devin take over and talk a little bit about BYD's products, I'm just going to give a quick introduction of RENVU if you haven't heard of us before and this is your first time joining us. So my name's Nick. I'm a sales engineer here. RENVU was founded in 2012, based out of Mountain View, California, very close to San Francisco on the San Francisco Peninsula. We've got fulfillment centers based on the West and East Coast as well as in Texas. Our entire sales team has an engineering background, so we can go very in-depth working with you on any of the design projects that you have coming up, be you an installer or a DIYer, even up to larger commercial projects. We don't just sell products, we assist with technical expertise, any kind of support that we can give during the installation and commissioning process, and even post-commissioning. We do offer additional services, including the Megawatt Club, which includes free shipping for all of your orders and discounts on engineering services and permit packages. Speaking of which, we also offer full permit plan sets, PE stamps for both structural and electrical, as well as site analysis and design. As well, we've got a number of online design tools. If you go onto our website, you can see the solar kit guide, which allows you to generate a full bill of materials for a project within 5 minutes, for everything from a battery system to a carport to a regular grid-tied residential system. In addition, we've got a lot of other calculators for inter-row spacing, battery sizing, sort of a wide variety there. We also offer financing options for larger orders on a project-by-project basis, and credit terms and residential financing for customers of yours through a couple of partners of ours. Just to talk a little bit about some of the products we carry, obviously BYD and Solis. Our products that we're going to be talking about today that we carry, great residential, hybrid, and commercial inverters. And the hybrid can be used for high voltage systems that we're pairing with BYD batteries that we'll jump into here in a little bit. Module-wise, we've really focused on the LONGi 450 and 355 watt modules for this coming year, as well as the Trina 395 watt. So you've got a really great sort of spread there of power density versus aesthetics and form factor. For the 450 watt from LONGi and then later on 540 watt from those, we are expecting a little bit of a lead time. So if you have commercial projects, expect to plan for an 8-week lead time on new orders. As well, KB racking, really great new ballasted racking option that we've just added. It's incredibly fast and easy system to install, and its price points makes it very competitive. NLX, another new product that we just added. We're carrying their Step 2 48 amp car charger. It can be used both in a residential and commercial setting. They've got different options there, and you can take a look on the website to see the differences. And last that I'll talk about before handing it over is Bleecker, which is a residential carport solution. And I'll go into a little bit more depth at the end of the presentation talking about that after we hear from both BYD and Solis today. So a couple of things before I hand it over. Just like all of our previous webinars, we are recording this one, and you will be able to pull them up on YouTube if you registered or are attending now. You'll also get an email with a link to that. If you have any questions about the products or about BYD and Solis, please feel free to ask in the Q&A section at the bottom. You can ask in the chat section, but it's a little easier for us to use the Q&A section. So if you do have a question, please try to use that. Or if you come up with any questions after the fact, contact information will be at the end of the slides here, when you can either contact BYD or Solis or email in at info@renvu. So I think that does it for me. So I'm going to go ahead and hand it over to Devin. You can go ahead and take it away.
Awesome. Thank you, Nick. And thank you to the whole RENVU team for setting this up. So yeah, my name is Devin Wilson. I represent BYD. And I'm here to talk about our battery box products. So I'm going to kind of skip all the salesy sort of stuff and just get really deep into the nuts and bolts of which products we offer, how they are configured with a compatible inverter, and even get into the installation process. The installation training, it's not going to be 100% thorough. We're going to go through every step, but we're going to keep it kind of at a high level. All the information comes along with the battery, so it's just kind of get your feet wet a little bit, get you to understand how the product goes together. Second. Okay, so what I'll do here is I'll cover a little bit about BYD, talk about our 2 battery box products, our current and upcoming product, and then get into installation. So first with BYD. BYD is a very large company. It's not very well known here in the Western world. We're one of the largest EV manufacturers, especially electric buses, and we're one of the largest cell manufacturers in the world. Reason we're not super well known here in the US specifically is we don't sell those cars, our electric cars here. So while we are one of the largest in the world, you don't see them on the streets. What you will see though is our electric buses. Major cities, Los Angeles, some others, are rolling out BYD electric buses. And then when we kind of drill down just to the battery box product, again, we're new to the US. We've been in the rest of the world, and in particularly Europe and Germany for a while now, since about 2015. And we're one of the top, kind of tied there in second place for market share when it comes to the residential battery sector. So very large company. This residential battery business is a very big business for us, but we're new here to the US, so just getting going. Here's a quick snapshot, battery cell production. This is, I bring this up just because one of the things that informs the quality and kind of abilities of our products is the battery cells. And to make a great product, you have to produce high quality battery cells, and to create high quality battery cells, you have to do it at volume, and you have to do it in an automated manner. So BYD understands the value, the strategic value of battery cells. We look to essentially double our cell production every 2 years. So it's a huge part of our business. It's our core competency. So getting into some of the battery box basics, I'm going to start with our current battery box HV. HV stands for high voltage. So what it is, it's a high voltage, indoor-outdoor, LFP, that's the battery chemistry, residential battery in 3 different sizes. So 5, 7.5, and 10 kilowatt hours. As you can see, it's a modular system, and it's built such that you're just replicating modules here to create the different sizes. So when you order our product, which I'll kind of show you some real photos later on, you're going to order, there's 2 SKUs, right? So you have the top and the bottom of the battery. The top is called the BCU, and the bottom is called the base. Those come sandwiched together in one box as one SKU. And then each of the white boxes is the battery module, contains the cells that comes in one box. So when you go to order the product, depending on how RENVU sets it up on their website, often you can either order a complete system, which is meaning those, for this 10 kilowatt hour stack, it's this SKU plus 4 of these module SKUs, or you can order the individual components. Either way, you can kind of stack it up into any size you want, and you have a lot of flexibility there. One quick thing, people often ask, I can see 2, 3, and 4 module configurations right here. Why can't I do a single module, and why can't I do 5 modules? And the reason for that is voltage. So it's a serial connection between these modules. Each one is about at 100 volts. And the inverters that we work with, they have an operating voltage range. So the reason you can't do 1 and the reason you can't do 5 is 1 would be too low a voltage and 5 would be too high a voltage. So that's why we're limited to these sizes. Installation conditions, on a very high level, it's indoor and outdoor rated. It can be operating in temperatures from 14 degrees Fahrenheit up to 122 degrees Fahrenheit. So it's got a really wide operating temperature or operating range, and that we owe that to the LFP chemistry there, which is it's a little hardier and more robust than the NMC chemistry. The only thing we recommend is when it's outside, protect it from the sun, right? You're trying to install this battery and have it there for 15 years. Really high temperatures are not great for batteries, and sunlight produces higher temperatures. So protect it from the sun, get it under an awning or something similar. We also have an upcoming product called our HVL. So we have our HV and HVL, L standing for large. So while our other product is 5 to 10 kilowatt hours, this one's 12 up to 32 kilowatt hours. And you can see you can get 6 different sizes. Same design philosophy, right? A modular stackable battery. And with both of our products, you can scale at any time. So if you start, say, with a 12 kilowatt hour battery, you can add modules down the line, 6 months later, let's say, and increase the size of that battery. One question a lot of people have when they see our HV and HVL is they say, will I be able to kind of mix and match modules from both systems? And the answer is no. There's two reasons for that. One is very simply, the modules have different physical dimensions, so they can't go together. But also, when you're creating a battery with a serial connection like this, you need to make sure that the voltage and the amp hours of each of the modules are identical. So even just kind of fundamentally, even if they could interact and lock together physically, it wouldn't work from a battery kind of construction, cell design, cell serial connection standpoint. So very quickly, kind of going through some of the advantages of our product, that flexible sizing and that scalability, that a lot of customers are unsure about storage. They're unsure about how much storage they need. They're unsure about how much storage they'll need a year from now. So the ability to choose either the right size if they have a specific size they're looking for, or to choose a size they think makes sense with the flexibility to grow that stack over time is a huge selling point. Additionally, that modular nature, it makes for an easy installation process. So we use an LFP chemistry, which is, I believe, the best chemistry for stationary storage. The only drawback of LFP is that it's a little heavier than NMC. So the overall battery becomes a heavier product in the end. But because this battery breaks into pieces and can be carried individually to the site, it actually creates for a very easy installation process. When you stack up the battery, which we'll get into a little bit later, it's all internally wired. So you're not in the back kind of connecting modules to modules. As soon as you drop a module on top of the other one, it's kind of like a Lego brick, all the internal connections are made. Lastly, one of the big advantages of LFP is the huge amount of power you can push in and out of these batteries. And that's hugely important for two reasons. One is you never want your battery to limit your inverter. If you're buying an inverter that has a certain power rating, you want to make sure your battery can deliver that power, or else out of the system, you're going to get the weaker of the two, the battery. Also, backup is a huge selling point here in the US. And when you're in backup, power is hugely important. So you want to make sure you're designing a system that can deliver the power you need in backup. So here's a quick high level on the two different sizes we offer, HV and HVL. Solis is compatible and will be compatible with both of these battery sizes. So getting into constructing a system, there's Solis Hybrid Inverter there, optional transfer switch for backup operation. But the inverter has one battery input, so you can put a 5, 7.5, or 10 kilowatt hour battery on there. So the resulting, for backup power, the resulting specs are essentially 6 kilowatts of power and 5 to 10 kilowatt hours of capacity. That's just for backup. Of course, it's a hybrid inverter, so there's other power ratings and different power classes for PV power, but for that whole range, it's 6 kilowatts of backup power. So a nice, good amount of backup power. We're also compatible with SMA and their Sunny Boy storage, which is an AC coupled storage only inverter. So similar setup, a transfer switch, an inverter, and a battery. With the Sunny Boy storage, it has 3 battery inputs, so you can do any combination of our 5, 7.5, and 10 kilowatt hour batteries. So it's similar power, 6 kilowatts of continuous power, and then 5 to 30 kilowatts of capacity. So those are the combinations with our HV. Jumping into our HVL with Solis, which is expected to launch this fall. The expectation is based on certification. We don't consider a product, a pairing launched until, of course, we've worked out all the compatibility and whatnot, but also certificates. We get UL 9540, which is the system level certificate for these products together. So similar combination as our HV, battery inverter, transfer switch, and then a battery. You can see a nice wide range of sizes here, 12 all the way up to 32. So the resulting output is 6 kilowatts of power, 12 to 32 kilowatt hours of capacity. Repeating that for SMA and their Sunny Boy storage. One thing to note here is you're seeing it's missing the HVL 12.0. As mentioned before, as you stack these batteries up, you get different voltages. And so sometimes some of these configurations are outside the voltage range of the inverter. So our 12.0 size is not compatible with the Sunny Boy storage just based on voltage. And then again, 3 inputs. So you can get 6 kilowatts of power, 16 up to 96 kilowatt hours of capacity. And we're also compatible with GoodWe. Similar setup, it's a hybrid PV and storage inverter, DC coupled, single battery behind this inverter. So 12 to 32 kilowatt hours of capacity. Okay, so I'm going to dive a little bit into the installation process. Again, I'm going to keep it high level, but if there are any specific questions at the end, I'm happy to get into any details, especially when we talk about the installation process with the Solis inverter and how that works in tandem. Just at a very high level, what we recommend is, you mount inverters on the wall, you construct the battery, you wire everything up, make sure obviously everything is turned off, battery and inverter and connection to the inverter. And then we recommend starting first with the battery. So turning on the battery, commissioning it. So there's a commissioning process for the battery, and then jumping to your inverter, turning on the inverter, commissioning it, etc. So I'm gonna drill down to that second step, that battery commissioning. I'm not gonna run, I'll quickly run through this, this process here. You can see there's a base here at the bottom. You're gonna level the base. You're gonna stack up the modules, locking them together as you go. I'll get into what that looks like. You're gonna put the BCU on the top. You're gonna wire it up. You of course have to construct it before you wire it. You're running conduit and whatnot, so that the location of those knockouts and whatnot are critical. Then once all wired up, you're gonna turn on the battery system switch. It's a breaker on the other side of the battery. You're going to log into the battery. Easiest way to do that is via Wi-Fi, but there's 2 routes, and we'll talk about that in a second. You can upgrade the firmware if needed. You're going to commission the battery. So essentially, you're just going to tell it how many modules it has in a stack and which inverter it works with. And then you're going to continue on to the inverter. So turning the inverter on and commissioning it. So diving a little bit into this process in detail. Again, so installation locations, as mentioned, indoor and outdoor rated. If outdoor, not in direct sunlight and not in direct rainfall. So under an eave, protected. And then definitely, don't put it next to a open flame and whatnot. The battery itself relies on passive cooling. So it doesn't have a fan in there or whatnot. So it actually has, as far as clearances around it, really I'll jump back to this side. Really the clearances are really dictated by access to conduit and access to breakers. But of course you don't want to put it next to something that produces heat and will heat up the battery itself. So that process for installation looks like this. As mentioned, single box comes with the base and BCU. Single box comes for each of the modules. The battery is floor mounted, which really makes for easy installation because it can go anywhere, and it has a base with feet that have levels on them. So often a lot of these batteries are installed in garages. The floor is not perfectly leveled. So you can set that base down, level that, start stacking up those modules. The only thing you have to do when you stack up the modules is put in this locking screw on each side of the battery. So all the internal connections, the DC connections, the comms connections between the modules is all done for you. You just mechanically lock it together. So here's what the different complete sizes would look like from our quick install manual here. We also have kind of incorrectly worded on this quick install guide a wall mount. It's really a lateral restraint. So in a lot of places where our battery is installed, there's seismic considerations. Also, while this thing is very stable, you want to make sure that if a car were to bump it or someone were to really push on it, that it wouldn't get knocked over. So included in the box is a lateral restraint, which I'll show a picture of that in detail, but it essentially attaches to the BCU there at the top on both sides and constrains it to the wall. And it's got some adjustability so it can overcome if there's some footing there at the foundation or whatnot. Then to make the connections, what you do is you take off the top cover of the BCU and you get access to the 3 connection locations you're going to need. So here's what a deconstructed system looks like. So I'll point out a couple of things here. In the foreground, you have the base and the BCU. But at each of these modules, you have a seal right here, a rubber seal, just to keep water and whatnot out. You have alignment pins, and then you have these connection plugs. So again, you're just setting each piece on top of the next, and it's creating all those connections and alignments all sorted out for you. Here's a photo of two fellows doing some work, putting these modules on there. As you can see, this is where those little screws go on each side just to mechanically lock it together. Here's the picture of that lateral restraint. It's got some adjustability, so it's able to be it doesn't have to be a set distance from the wall. What a lot of people will do in this situation is, depending on the location of these lateral restraints, are dictated by the width of the battery, which wasn't dictated by stud distances in US homes. So what often people will do is put a piece of unistrut behind the battery there and bolt that into the unistrut, and then the unistrut can sit on whatever studs are needed there. So getting into the wiring, just from a high level, when you're doing the wiring for the battery, you're wiring it to the inverter, right? The battery always sits behind the inverter. The inverter is the one that makes the decisions about charging, discharging, what's going on in the home, because it has visibility. The battery doesn't have that visibility. All the battery does is it communicates to the inverter and says, hey, this is my state of charge. And the compatibility is worked out that the inverter knows what to do. Of course, the battery has ability to protect itself in case there's malfunction or something similar. So it's got breakers and relays and whatnot inside of it. But for the most part, it just communicates its status to the inverter, and the inverter makes decisions about charging, discharging, and all of that. So the connections you make at the battery are DC connections and ground, and then comms connections here. So the comms connections, it's a simple Ethernet cable. You're going to follow the instructions that come in the manual. I'm not going to dive into them too detailed here, but depending on the inverter, it's a slightly different connection. These comms pins, so here's the open top of the battery. You're actually seeing a lot more than you would normally see. A lot of this is shrouded behind hard plastic, but I figured it was a fun thing to see everything that's going on in there. There's where those DC connections are made there at the top, and then comms connections down here. Here's that comms cable. So it's just lining up the pins, inserting them, and doing the reciprocal on the inverter. So there's a shot of that comms plug. There's also an Ethernet connection. The battery doesn't need to be Ethernet connected. What that allows is for some remote monitoring and similar, but it doesn't require an Ethernet connection to be compatible and to work with a Solis or other inverter. So that's just an optional connection. A lot of people find it hard. You already have maybe an Ethernet connection for your inverter, finding router space for an additional one for the battery. So it's not critical. So then the last little bit of the puzzle is just commissioning the battery. So this is an important point. Obviously, people don't instantly realize that you need to commission the battery. All you're doing is you're essentially logging in either via Wi-Fi or via Ethernet cable. Wi-Fi is actually very simple. As soon as you turn on the battery starts creating its own Wi-Fi, and all the login instructions are in the quick install guide here. But you log in and you commission, and what commissioning is you set the time, you tell it how many modules are in that battery stack, so 2, 3, or 4, and then you say which inverter are you working with. So SMA, BYD CAN for Solis inverters, and then you say what country you are. At that point, you're going to say next. It's going to reboot the system, and it's ready to go. And at that point, you don't have to commission it again. Even if you turn off the battery, you could turn it back on later. It knows what it's got going on. Obviously, if you make a change, if you change inverters, I can't imagine why you do that, but if you changed inverters, you'd have to go back and recommission. If you changed how many modules were in the stack, you would have to recommission. One little watch it is this kind of trips some people up. When you're logged in here and you commission the system, it actually reboots itself. And since it's internally created Wi-Fi, when it reboots itself, you actually lose that Wi-Fi connection. So one thing that can kind of trip up new users is they might stare at the screen waiting for it to refresh. In reality, it's done. The commissioning process is finished. You just need to refresh the web page. It's just the Wi-Fi connection's been lost, And so you're looking at a dead web page. In the battery, so for the most part, a user and even an installer, you're going to interact with the inverter most all of the time. The reason is the inverter is the smart one, right? It sits at the center of the system. It has visibility of everything, you know, the home loads, the grid connection, the PV, and the battery. So it's really the quarterback of the system. But you do have the ability to log into the battery just to kind of look at some things if needed, especially if you're troubleshooting an issue. So one is you can look at the firmware version right here in device information. That can be updated. The update process is very quick. You essentially just download the file from our website, upload it right there on the battery. It takes about 30 seconds. You can also take a look at kind of what's going on at a deeper level on the battery. So you have total voltage, pack voltage. I'll get into what those two mean here in a second. State of charge and alarm state, right? There are some of the key ones. You can also, this is that device information page, looking at the version and whatnot. And then installation config page. This is, you know, you've commissioned the battery. You want to make sure you did it right. You hop back in here. You can see the settings you did. Okay, this is a stack with 7 modules. The inverter, this is from Germany, obviously is a coastal inverter. So you can verify that what you did was correct there. Okay, for the last little bit, I wanted to run through a couple of watch-its when you do an installation. These are things that just make the installation process go much smoother. The first is these alignment plugs. They're robust and they have some give to them and whatnot. What we want to make sure is when you set the modules on each other, just set them down in a kind of controlled vertical manner. You know, it's hard to damage these things, but we want to make sure people aren't kind of being really rough with them and dropping them in at a weird angle or anything like that. So as long as you put a little bit of effort, it's all good. Additionally, one thing to watch out for is, you know, the modules themselves are very heavy. They have a bunch of cells inside of them, so they can hold them. They can press down that seal ring below them very, very easily, just with their own self weight. The top, the BCU box, is just a PCB in there, right? So it's very light. And so as a result, sometimes when people put it on there, it's not snugly connected. So what we just recommend is just put a little downward force on it as you lock it. You do the lock screws on each side. Again, you're not going to cause any battery damage if you didn't put it on snug enough. You can have some internal comms connections issues, and so that can avoid that. The other thing is, if you do run into an issue where the inverter isn't recognizing the battery, first off, we have, you know, support at all times, so you can always call into support. But what we recommend is people make sure they commission the battery. You know, a lot of people kind of, if it's their first time, they forget about that step. They go, okay, I've stacked it up, I've wired it, I'm good to go. You need to commission the battery. You can always log into that battery home screen and check for errors. You know, if there's an alarm state, give us a call right away. Another one is that comms wiring. Yeah, sometimes people make a little mistake. You know, you're there outside, it's hot, whatnot. You make a little mistake with your comms wiring, which pin fell into which. Just give that a review. Always try configuration on the inverter one more time, and then call our service line. We're always happy to help. And usually it's a simple process. Obviously mistakes happen, but we're happy to help you and walk you through all that. One thing, this is one thing to look out for. This is a common mistake as people think they're diagnosing an issue. So, you know, the battery, the brains of the operation is at the inverter, but the battery has a lot of smart features in it, a lot of protections and whatnot. So one of the things it does is it has an open relay inside. So when you first turn on the battery, it's not just giving power to those DC connections going out. So if you stack up the battery and you turn it on and you take a multimeter and you read the voltage across these connections here, you're going to get 0 volts. So on our nomenclature on our battery, there's total voltage and pack voltage. Total voltage is the internal voltage of the battery. So that's just the native voltage of what's going on in all those cells. And pack voltage is the voltage that's being applied to the terminals right here. So one of those safety features is that it's not just going to instantly energize those terminals right there. What it waits for is it waits till it begins communicating with the inverter. So what a lot of first-time installers, what a mistake they make is they stack up the battery, they turn it on, and they take a voltage reading and say, I'm getting 0 volts, the battery must be dead. That's not the case. It just needs to be commissioned and it needs to be communicating. And then that handshake occurs between the inverter and the battery, and then it's going to apply the voltage. So just more of a watch it, because people think they've discovered a big problem, and it's not a big problem. The thing you want to look out for, is there an alarm? Give us a call if you see any sort of alarm. We can help you sort it out. And then the very last point, these batteries are very robust. They have an LFP chemistry, which it just does very well. It can be cycled fully. You don't have to, you can be pretty rough on the battery. Also the battery will protect itself. So in the event that it's not able to recharge itself and it's being drained, so let's say there's a malfunction going on and the inverter keeps wanting energy out of it, to power loads, at some point the inverter in the battery can turn itself off and say, hey, I'm just really, really low. I need to protect myself and turn it off. So there's not a huge risk that you're ever going to really damage the battery in a long-term sense. But what we want to avoid is just a more lengthy service case, in the sense that the only time we see problems is if an installer is at site, they have an inverter that they haven't commissioned, they haven't finished the inverter process, and they have a battery commissioned and communicating with it. And so you have a situation where the battery is powering the inverter. So the inverter is needing that energy to go. And the problem with that is that the inverter will just keep using up the battery power until it gets really low and the battery turns itself off. Normally that wouldn't be a problem if they were working, if both were working. If the inverter was working, we would just turn on the battery, we'd turn on the inverter, and it would start charging it. Say, hey, I'm really low, inverter would start charging it. Often though, you need time for troubleshooting and whatnot because you're working something out on the inverter. So the long story is, what we recommend is, if you're at site and you're doing an install and you're not at the point where the installation's finished, just turn off the battery before you leave site. When you come back to site, you can turn it on and you'll have hours of time to work with before it needs to be communicating and able to charge. So don't want to scare anyone, of course, but it just can save you time if you don't have to send an external DC charger and have you charge things up. That's usually always avoided, even in these situations where someone leaves it on, but it's just best practice to always turn off the battery before you leave site. And always remember that it's a battery with its own energy in it. So from a safety standpoint, just make sure you're always thinking about that. You may have the power turned off on the home. The battery has its own energy internally. Obviously, it's a battery. So keep that in mind. Make sure you turn off the battery just from a safety standpoint if you're not working on it and whatnot. Okay.
Yeah, I can follow up with that, Devin. We, as you note, you can't really check the voltage there until you're communicating with the inverter. So during that commissioning process, there's no LEDs, for example, on the outside of the BYD box. So, and the switch itself actually is kind of easy to operate. It's protected by that cover, and so it just is best practice when you're doing your system setup to get your battery set up. You know, you're doing some of your wiring, just shut her down before you get fully commissioned. And so I can, that was just great. I learned a lot actually in that, and I'm able to relate to that a little bit as I've recently commissioned some BYD batteries, and yes, we had the wall mount to hold it securely to the wall, and the way they stack up, it's such a small footprint, you know, either in the garage or in one case a basement. It's really nice in that respect. So with the Solis inverter and that skinny little ATR to an auto transformer to give you 120/240 split phase at your critical loads panel, and that stack of BYD, it's actually kind of a nice tight footprint on the wall and in the garage. So we like them a lot. You know, BYD is a company that's been around a long time, and so is Solis. We are a go to the next slide there, and indeed we are a global manufacturer. When you're seeing this inverter here, you're seeing an inverter that's UL listed, but really has been listed around the world, TUV and EU and other places for more than 8 years now that we've been doing hybrids. And so it's really a proven platform, and from a global manufacturer. Natasha, do you want to address a little bit about Solis and Jinlong Technologies?
Yeah, sure. So first, guys, hi, I'm Natasha Hood. I work with Terrence, and thank you, RENVU, for having us. And, you know, Solis has been in the industry since 2005. We've been in the United States since 2009. We are one of the oldest inverters in the US and globally, actually. We continue, our factory has a 20 gigawatt capacity. We did over 9 gigawatts just last year, and we continue to grow up, grow and grow and grow. And also we, since 2019, have been publicly traded, so you can actually see our revenue. So we are a very bankable, reliable company. We also own our own manufacturing, own our own R&D. We also, I'm proud to say, I feel we have the best customer service in the industry for inverters. We basically have a hotline that's all US based. We also have every call is being fresh desk monitored. And we basically have even, you can go to solisinverters.com and see our inverters and also see our after sales support, where you can even do a bot. All our error codes are Google searchable. We try to be very customer friendly with our product. And we're really glad to introduce our hybrid storage inverter. I can't say introduce since we brought it out last year to the US. And have partnered with BYD on this product. As you can see, we're also compatible with LG Chem, Pylon Tech, and Soluna, trying to offer you guys flexibility in rapid shutdowns and batteries. And we try to be a flexible, customer service-oriented company. And so thank you guys for attending. And Terrence, I'll let you continue the deep dive of our hybrid storage inverter.
Thanks, Natasha. I've been working with Solis now since April 2016. I've seen them grow from their 5 gig factory up to this new 20 gig factory. The company's never been in the red. It's really grown steadily through the years. And as Natasha mentioned, we were first UL 1741 listed here in the US in 2009, and we were white labeling a lot of our products through Sunrun and even today through Canadian Solar. And so even though globally we're ranked number 4 in PV string inverters, you don't hear our name as much, and it's only been in the last few years, since 2019 I guess, that we've been really trying to promote our Solis brand name. String inverters, PV string inverters is what we do, and indeed what you're looking at here is a PV string inverter that's battery ready, essentially. It's the same sort of inverter platform that we use around the world. This particular enclosure is NEMA 4X, and it's unique here in the US in that it has a wire box below that accepts conduit, whereas most of the inverters that we supply around the world just directly are wired with PD wire, double jacketed wire right into MC4 connectors on the bottom of the inverter. But here in the US, we have this really generously sized wire box where you can fit, you know, guys' hands in there to do wiring on our really positive terminals, spring terminals. I really like them. They really give a really great connection. These are, there's fused battery terminals in here, and there are both RS-485 and CAN bus connections for your battery communications. And indeed, we'll be using the CAN bus type for this particular inverter and the BYD configuration. Now, this one is a DC coupled solution, essentially. Now, it's very versatile. It can be used essentially as a battery management inverter with no PV at all. Instead of an AC coupled solution like you saw Devin introduce with the SMA product there, an an AC coupled kind of battery management inverter. Essentially, this inverter does the same thing, except it's DC coupled, but it has the advantage that you can add PV later. Now, a lot of folks will actually install this product as a grid tie inverter that's battery ready. That's the kind of versatility I think you get with a kind of hybrid that you have today. Now, that involves, like Devin said, some more commissioning processes than you would have with just a simple grid tie inverter. With a hybrid inverter, the battery the inverter self-configures for the grid tie, anti-islanding and all that kind of functionality. And of course, this is a Rule 21 capable unit that can do volt var, and can do it does ramping of both voltage and hertz rate, that sort of thing. And so when you set up one of these systems, you really are just have the inverter itself. It does battery management, it does the PV. You can set up these systems, as you saw, we have 5, 7.6, and 10 kilowatt inverters, and those inverters really all output the same 6,000 watts. And so these inverters are really ideally set up for systems with short duration power outages and TOU and self-consumption of all the solar kilowatt hours that you collect during the day. Now, what are the parts that you need? Now, as Devin said, you just need that stack. It's so beautiful because you have, you know, your whole system is just in one piece like that. And with the wall connection and the base, essentially that's almost all the connection. Could you go back to that last slide, please? Could you go back to that? Thank you. And so when you're setting up these systems, you will have the BYD stack, and then next to that, you'll have the inverter, and you have to make sure that the inverter has good airflow from top to bottom, because just like the BYD battery, it's an air-cooled, passively cooled device. And so you want, with our inverter, you'll see there's a big heat sink behind, and you just make sure that that chimney effect, the upper and lower part of the inverter, has good clearance. So, but you can put a battery and the inverter fairly close to each other, within a few feet for sure. And so what are the parts do you need? Well, the PV array, and you might need rapid shutdown with that, depending on which jurisdiction you're in. You might be able to get away with string level rapid shutdown, or even no rapid shutdown at all if you're setting up this battery, you know, with a larger HV battery and maybe with a couple of other inverters. You may be able to get a pretty good outdoor type of system where you're actually ground mounting the PV array. You may not need to do some rapid shutdown, but in most cases, especially residential, on rooftops, you're going to need to do some sort of rapid shutdown. And if you're under 2020 or 2017 code or above, you're going to need to install these rapid shutdown receivers up on the roof. The transmitter, don't worry about it. Like I said, you've just got a one-box solution with the hybrids. The transmitter's already in there. So as soon as you apply AC power to our inverters, you are getting a transmission of a signal to either AP Smart or Z-Run type, or what we call SunSpec PLC type devices, or you can use Tigo, or like I say, none at all. But you're likely going to need the hybrid inverter piece itself, the rapid shutdown devices, your PV array, and if you want to do backup, you're going to need your auto transformer, and Solis has that can do 120/240 split phase. And you're also going to need a small meter that comes with the hybrid inverter in the same box. It includes 2 CTs that you're going to put on the L1, L2 of your service panel where you're making your point of connection. And this device is going to tell the inverter, communicate with the inverter with the same kind of wiring that you saw on that BYD wire. So you're actually going to have 2 communication devices coming into the hybrid, one from the battery and one from this power meter that comes with the inverter. And once you get those 2 dudes wired up, you're essentially now ready to commission the inverter. And like Devin says, it's kind of the heart of the system. And so you'll be able to commission the inverter in different kinds of ways. Let's go to the next slide. And this is, I like to talk a lot about this inverter because essentially you see 5 different ways you can set this up. And essentially I've talked about a 6th way too. Instead of simple grid tie where you're just connecting PV to it, where the inverter's battery ready for a customer who really doesn't have a lot of power outages, doesn't have issues with that so much, and doesn't have split kinds of pricing in their electricity co-op or their electricity company, or the utility they work with. You know, they just really want to try to reduce their carbon footprint a little bit. They want to, you know, reduce their monthly electricity bills. And so they're setting up as a grid tie inverter, but that would be kind of nice to have that grid tie inverter battery ready. You know, we might want to stack a small BYD system there for later, and then a little bit larger one as we go forward, you know. And so setting up a grid tie system with a grid tie inverter that's battery ready, it makes your homeowner a little bit more versatile, and maybe gives you an excuse to come back to and sell them a battery later on. But generally, you know, we like to use when you put in one of these inverters, the working mode that you're just sort of default set to is self-consumption, where you are really reducing your greenhouse gas emissions and you're lowering your carbon footprint, because essentially the battery will absorb any kilowatt hours that aren't being used by loads, or and then fill itself up during the day. And then as the solar power reduces, the sun sets and your loads come on, in the evening, the battery will discharge to soak up and make sure that you use all the solar kilowatt hours that you generated that day. So that's the default mode. But but in California and a lot of places, you can actually increase the return on investment and decrease your payback period by putting in a battery. You can put in a battery and really take advantage, to kind of do some arbitrage with the different pricing in let's say California, for example, where you might be a 30 cents delta between the off-peak times and the peak time. So having a battery there to really fill the load's needs during those peak hours can essentially reduce your payback period. So together they really work well. A DC coupled battery solution here can pay itself back faster than almost any other solution, because of the buy-in price being lower than other residential solutions. Now, indeed, TOU is another thing you can do, just to install your battery, calculate how much you typically use during that 4 or 5 hour period, and you can essentially really get good payback on your battery system by in those zones, in those jurisdictions. Now, this system can also act as a backup power system. We don't like to call it off-grid, truthfully, but essentially you can live off-grid with a big enough PV array and a 30 kilowatt hour a BYD battery. This DC coupled grid tie system, this hybrid system, can live off-grid essentially indefinitely. When you buy a Schneider or an Outback system or something, you've got 60, 70 amps capability output. Correct me if I'm wrong on that in the chat, but you are essentially the utility. But Solis is coming up with a new a set of inverters that can kind of be stacked up a little bit more, so you can take full advantage of delivering even more than 6 kilowatt hours of power. Look for that coming up here for Solis, but look at all the different ways that you can kind of check out the use case that your customer really is talking about. What do they imagine that the solar system with this battery is going to do for them? And you can then program the inverter, whether or not you want it to just make sure that they use all their kilowatt hours, to make sure that they're ready for any off-grid systems. For example, you might want to limit the amount of discharge of that battery to 80%, so that in case any time their power goes out, they've got essentially almost a full battery to back up. Well, in the case I was just at, or their sump pump. They're very concerned about, making sure that their basement doesn't flood, so they got to have power for that sump. And so we calculated how much it would use over, a typical 12 or 15 hour period, and we calculated that battery for that backup power. So should you go off grid or the battery go out, these types of systems can be set up for those kinds of emergencies. So the versatility of these hybrid systems with the BYD battery, I think it provides a great value proposition for anybody reselling these products and talking to customers about not only reducing power bills, but also giving some true security and resiliency to their homes with these kinds of systems. If you have any questions about what I just went through there quite quickly, please put them in the chat or in the Q&A section, and I look forward to hearing from you. Nick, you want to take over?
I will take over from there. Thanks, Terrence. And thanks, Devin and Natasha, as well. We'll get to the questions here in a second. I'm just going to talk a little bit about Bleecker, our residential carport solution, and tie it in a little bit with everything we've just heard. But jumping in, if you haven't heard about it yet, it's a residential carport solution. It's designed and built here in the United States, comes with a 25-year warranty, incredibly sturdy design. Its base setup is for snow loads of 35 PSF. but can be upgraded to 65. Base wind load is 130 miles per hour, but can be upgraded up to 175 for some areas where it's required. It's designed to be incredibly easy to install. It comes in portions, so it can be delivered on a flatbed truck, and then unpacked and pieced together and done either by an installer or a DIYer without any heavy equipment needed for the installation. So it's light on tools, very versatile, and it can be sort of configured in different ways, which we'll talk about here in a minute. So getting into it, we also, this is how it kind of ties in, offer it in kits where you'll get an entire setup of the carport, the modules, the inverter, energy storage, and an EV charger. We're designing them with the Trina 395 watt 60 cells, and the kits will include, if you're going with the energy storage option for it, the Solis inverters and BYD battery system. So you basically are offering a full, complete kitted solution to your customers who may or may not have roof space to utilize or ground mount space, but have a driveway that they want to put a carport in. There's some added sort of amenities that you can add on as well that I'll just talk about. There's solar lighting, so you can have that added onto the piers to provide some lighting for when pulling cars in. There's this silicone or EPDM gasket, T-gasket, that can be used to provide a full flush surface on the top to prevent any water coming through. There's a sail that we call that you put underneath, a cosmetic sail that will cover the back portion of the modules and the wiring, so you get a nice clean finish underneath there. And like I said as well, the NLX car chargers. So if you have your EV charger, you can pull your car right up underneath the carport and have your EV charger with the integrated cabling being powered from the solar or from your energy storage there to charge your car. As well, there's an authorized installer program. So if you are an installer and you're looking for carport solutions, very simple. You submit an application. You'll do 3 installations. You'll sign the SPA, and then after that, you'll immediately get $1,000 per carport as a rebate. And then from there, you'll have, I believe, usually the base is 5 installations per month, and you'll receive rebates based off of those installations. But there's some flexibility in there as we start the programs. So you can always ask about that program as well afterwards. And then if you take a look here, there's the solar kit guide I spoke about earlier. You can design systems with solar carport kits in there, or piecemeal it together with, inverters, storage, racking, any components there. Very straightforward, very user-friendly. And as you're going through, you can see it's generating a bill of material on the left there, along with system summaries and information. If you don't know the specifics as well, there's a lot of calculators that are built in there, so you can decide on sort of the fly what you might want if you don't have specific products that you've chose out or sizing for the system. If you're logged in as well, you'll see the pricing come up on there. And you can see here we're getting into the battery banks and the energy storage sizing for the system. So there's a lot of tools there for actually figuring out what you might want, as opposed to going in and knowing ahead of time already. So it's a very straightforward, very useful tool. We've got videos that delve in to the actual use of it on our YouTube page if you want to take a look, but feel free to jump on the website and play around with it and generate some projects. Cool. So I think we can jump into the Q&A section now. I don't know if, Devin, you want to jump back in here and we can start just taking a look at some of the questions that have popped up. I think several of them. I'm
happy to do that. Yeah, so I've been trying to answer them in the QA, but there's a couple that keep popping up, so I wanted to kind of answer those live as well, cool. Just because I figured a lot of you were thinking about that. So one of the questions that comes up quite a bit is about extension of the battery. So let's say you install a 5 kilowatt hour battery or 7.5 kilowatt hour HV, or with our new system, let's say a 12, adding modules as you go. And so there's some people have brought up a couple of questions and whatnot related to that. So the first is just that process in general. The one thing you have to do when you're doing that process is we want to see SOC alignment, so state of charge alignment between the new and the old. So what that, there's some kind of wiggle room there, but what that looks like is we know the state of charge of batteries that of modules that get shipped to you. It's regulated. You can't ship a fully charged module, so you're going to see modules at about 25–30%. And so what we want to see is when you're adding modules to a stack, that the stack is within plus or minus 10% of that. The battery management system will, it actively balances all the cells and the modules in the system at all times. It's just part of the process. And so it can resolve those little differences. It just would take a lot longer to resolve a bigger difference. And so we want to see that alignment before you add modules to the stack. So easiest way is if you're planning on doing that, if you have a system and you're going to add modules, just shoot our service call, our service line a ring or an email, and we'll kind of talk you through the simplest way. It's usually easiest to set up the stack, so when you arrive, it's right at a state of charge that you want. So that's that first aspect. That's the process of actually doing it. The other question that was often coming up was, when does it stop to make sense? So if I have a battery, at what point do I say, oh, I don't want to add modules to it because of some considerations? And what those considerations are is that all batteries degrade over time, right? So you lose a little bit of capacity. And when you look at our highly accelerated life testing, what we see is if you used it every day, we would expect you to probably have about 80% capacity after 10 years. So when you add a module to that stack, it's going to kind of mirror the degradation. The new module is kind of going to align in the degradation of the old modules. So if you were to add a module at the 10-year mark, you'd really be only capturing about 80% of that new module. So at some point it does start to not make sense, just because of that, you're kind of chasing that degradation. So what we recommend, first couple of years, it's totally fine, especially people, we did this very aggressive full cycle, everyday, highly accelerated life testing. You're not even gonna degrade your battery that much. So first couple of years, it's totally fine. You're just gonna lose out on a couple percentage points. Once you hit the 5-year mark, I would start to think about it. Additionally, we have the expectation that in 5–7 years, the where batteries are going to be wildly different in pricing and all that. So it might not make sense to add a single module at that point. You might just be adding another stack next to it, that sort of thing. But we definitely have a lot of people. So we've been selling our HV since 2017 in Europe and in Germany. Huge storage market, sold a ton of them. We have a lot of people that have extended their systems, enlarged their systems during that time, 1, 2, 3 years after the fact. So yeah, it's definitely done, and it's totally doable. Getting into some of the other questions. So how is SOC determined at the time of onset? So SOC, so state of charge, is actually a complex calculation for batteries. At first blush, it would seem simple. How full is that tank? But it's actually complex, and it has to do with the way battery cells, the voltage changes on battery cells. But what the system does is it calibrates its SOC at all times. So as it's being used and as it's discharging, it's taking these measurements and running an algorithm and figuring out its state of charge. So right away, when you first stack it up and it's kind of a static state, you first flip it on, it's going to show a generic SOC. But then very quickly, as it starts to be used and the inverter starts pulling some of that power, it's going to readjust and start calculating that SOC. And then within that day, it's going to have a really precise understanding where the SOC is. But that's just something to think about. The batteries modules, as mentioned, they ship at roughly 25% SOC. You can't ship anything above 30% per rules. So you would expect when your system arrives, it's going to be about 25%. That sounds like it's low. It can sound scary to some installers. Oh, my battery's only a quarter full, but that's a ton of time for it just to power the inverter and power itself to do all those things. You can get it up and running very, very easily in that time. You have multiple hours of working with it. again, we just want to make sure if you haven't finished the process, you turn it off before you leave, because we don't want to power the inverter overnight if it can't recharge itself. So going through a couple more of these. Let's see if I have anything else. No, that looks like most of them.
Yeah, I think that installers just may have had a bad experience with maybe old lead acid batteries or something like that. They just hate it when they get them really, really low. They're worried, you know, that who knows, somebody left them on the basement floor or something, you know, the old wives' tales of lead acid and things. But the whole lithium structure and how it can remain at low capacity for long periods of time and not affect overall the wide temperature range, the ability to add stacked batteries later on and extend the investment that you made, you know, 10 years ago, you know, extending it another couple, 3 years, that's something you can just never do with lead acid batteries and things like that. And so the versatility of that platform is really great for installers, in my opinion.
Yeah, for sure. When you compare them to lead acid batteries, they're just way less fickle, way more robust. You're cycling them completely. You're not worrying about dipping below some voltage and killing the battery. It's all kind of, the communication's all worked out with the inverter, so it knows what to do in situations. If it won't discharge the battery below a certain limit, it'll say, hey, I'm going to stay on, but I'm going to wait for charge. It's just way more user friendly. And just protects you from really damaging the battery, which is great.
But the old lead acid stuff, you never had to connect communication wires to the inverter, whereas these batteries you do. So you become a slightly more sophisticated battery installer when you go into this type of system. But once you get it down, you'll see that for example, that commissioning of the battery that, you know, that Devin recommended you do even before you get the inverter fully set up. Once you get the battery powered in, you might as well just turn it on and you can commission it there. And that step is not difficult. I didn't use the Wi-Fi, Devin, last time. I just used a cable from my laptop to the RJ45 jack port there, and it was a 5-minute process. And but that has to be done. And I just don't think that new installers will have much problem with that. It's just a step that needs to be done, that you need to understand that the inverter needs to hear from the battery what's going on. And so that communication link has to be good.
Yeah, exactly. It's a tiny bit more complexity to install, but it just protects that system and makes sure that system works really well for the long haul. There was one more question about when does the warranty period start? It's kicked off by the installation date. There is some language in our warranty about a certain time after being purchased. So we don't want you to purchase it and then install it 5 years later and say, I'll kick off my warranty at that point. So I can't remember the exact, I think it's 6 months or something like that after purchase, or something 3 months along those lines. So it's kind of the lesser of the two. But I can say from my experience, BYD is very generous with their warranty. For this product, it's a 10-year warranty. And we're not looking to wiggle out of every warranty claim. We have a very robust product, and it's tough to really damage it. So it's more just about service and helping you out and making sure we're working through any service issues. And that's our goal.
And a lot of times those service issues pop up through the inverter. And so the inverter service team is going to be essentially your front line. And we know the BYD battery. We're familiar. We communicate with Devin and BYD here and in China. So our team is capable of supporting this solution. And as Natasha mentioned, we consider our service team to be the #1 service team in the U.S. right now. We track all our calls. We on our inverter, we only have 27 alarm codes, and all of them are Google searchable, as we noted. But should you see some issue with your system, it'll come through as an alarm through your mobile app, and you can call up or watch video or see a solution paper on our website before you waste time going to the site. And so, you know, string inverters have really changed over the past few years. They've now become a two-way inverter communication platform, right? With the new Rule 21 stuff, now through the Solis cloud, we can communicate two-way communication with the inverter, which was something only, module level power electronics used to be able to do. And with the DC coupled solution, there are some things that an AC coupled solution can offer, but with these new inverters, the new string inverter hybrids, you can really do a lot. Like I say, you can do battery management alone, you can do PV grid tie alone, and then you can, with the versatility of the BYD platform, you can start out with a small inverter and use a big battery, or start out with a big inverter with a huge PV array and a smaller battery that you want to stack up later. Lots of options. Really appreciate you giving us the opportunity, RENVU, and Nick and the whole team over there, to give us an opportunity to talk about solar and about how these systems can meet so many different customer needs, from just wanting to start out with solar to a full-blown system that has backup capability for relatively long duration. Good stuff.
Yeah, absolutely. And we're happy to have you guys. It's been great so far. I think there's a couple last questions, but I don't know if you want to address those kind of just via text there, Devin. I think they're directed more towards I guess there's actually one question there about vehicle to load being incorporated into the hybrid inverter, but I think that's something that's is maybe a little off.
I can answer that. I can answer that one. I mean, essentially, the inverter needs an interface for the EV, and we're looking at that today. How possibly the EV battery can also be sent to applied to load, and we don't have that system yet in what we're calling our 5th generation hybrid today, but it's a technology that's known, and so we're looking at how we might do that elegantly.
Great. And then I think the last one on there was about firmware updates and introducing malware, but that might be more of an offline question.
No. I mean, it gets to a big concern with our inverters. I don't think with so much with the batteries as I don't think hacking into the battery is a threat you're seeing too much today, Devin. I don't know, but we are seeing cybersecurity issues as we tie these systems into the utility networks via our client aggregators and things like that. And so security is an issue, and it's being discussed in the SunSpec group and other places how we can set these systems up. But like I say, if you can connect these systems to the Solis cloud and be fully interconnected or not. And so there's always that possibility too, that these systems are capable of off-grid and they will continue to work in a cyber disaster. But like I say, I think that's something to think about. And
one of the things also, though, if you ever look at when it comes to cybersecurity, when they do a cybersecurity inspection of, let's say, a solar power plant, they don't include the inverters in that, and that is because the inverters, they don't have control over shutting down the grid. They're not capable of doing that. So if that's your main concern of control in those forms, inverters aren't capable of that.
Great, cool. I think that is all the questions. If anybody else has anything, feel free to contact us at any of the contact information listed here. You'll get an email with all of this as well. Want to thank Natasha, Terrence, Devin again for coming and joining us and talking about their products and how they marry really well together. We're excited for all of it, and hopefully be able to talk with some of you in attendance here about some of the projects you have coming up and how we can use BYD and Solis on them. Cool. All right. I think that's it. Thanks again, everybody, and we'll see you all soon.
Thank you.
Thanks for coming, everybody. Appreciate your time.